the similar structure as the International Space Station. The objective of this paper is to present an idea that could be used to send first manned mission to Mars. The technology considered is the engineer of the ISS. This is the assembly of different modules to build a large space vehicle capable of transporting a crew and support it for a long period of time. The mission must carry on enough supplies to sustain life. Some elements are added for the actual landing. These measures assume some factors that are mentioned in this slide and in the next one. The structure will be assembled in orbit, so the modules must be sent from Earth previously. Also, the crew that will become the Mars exploration crew should be sent to the ISS to perform the assembly and test. At this time, the ISS crew will work with the Mars expedition crew for the preparation of the vehicle. Because of the length of the journey, the assembled space vehicle must consider modules and equipment to sustain life for the mission, and to be able to solve any technical issues by its own means. After the first expedition to Mars, the contributions to the space program will be in the field of long-duration missions and mainly in the autonomy of the space vehicles from Earth. The experience will help to identify the best landing techniques and will prepare the way for future exploration with longer expeditions on the surface of the planet, and evaluate methods of send supply to the orbit of Mars. The first visit to Mars by humans will open the way for longer expeditions after learning more about the Martian environment and long journeys in space. For instance, some new ways to generate energy can be studied, using solar wind for the journey, or capture and process atmospheric particles on the surface of Mars. As any other space mission, all the risk assessment need to be studied to identify what elements must be redundant. Mission operation. The orbital space vehicle will act as mission control for the landing modules as hit by Earth, but capable of taking decisions if needed. Because of the length of the journey, the crew should have activities different than mission tasks. Also, to support life, the vehicle should have recycled processes as independent from Earth as possible. The spacecraft description. TSV is the vehicle assembled in Earth's orbit that will take the crew to Mars. It's like a space station with the functionality to travel in space. MLV, this is the vehicle that we'll use to land a crew of Mars and return it to the orbital TSV. It has a landing section and an upper stage that will the crew compartment and the propulsion system. MCQ, this is a model where the crew will live while in Mars. Its landing is unmanned and controlled to arrive safely to a certain location that must be reachable by the crew with the Mars rover when they arrive. The UNV, which is the unmanned Mars vehicle, as in the case of the TSV, the vehicle is assembled on Earth in Earth's orbit, docked to the ISS. The unmanned environment evaluation proof will be sent to study the Mars atmospheric condition before the attempted landing takes place. Should send information about wind velocity, temperature, density of particles, and other factors. The crew supplies container an unmanned element carried to the TSV and will be released to land on Mars when the TSV be on Mars orbit. The successful landing of the unmanned crew quarters, and this model will determine the length of the surface exploration. The TSV elements. The assembly of the space vehicle will be done by dock to the ISS. The models will be received from Air and will be docked, energized, and tested. The main vehicle will consist of a support structure similar to the truss of the ISS, solar panels attached to it, batteries to store energy. Crew quarters that will be the main module for operations and linked to the ISS. A lab module with a cupola. This module will be used to perform all the observations while the vehicle is on the Martian orbit. Also, this module will link to the landing module, which will be used as a laboratory on the Martian surface and will be sent to the surface before the crew landing. The lab departure receiving module is the laboratory where the landing vehicle is docked, and hence where the crew will depart and will be received after the surface exploration. This module has an external platform which will contain the unmanned evaluation probes and RMS to capture and returning the vehicle after leaving Mars. The Mars samples can be placed in this platform inside a container. The crew landing module is the space vehicle that will take the crew to the surface and back, and two propulsion modules to be used for the journey to Mars, course correction, and to reduce the speed to be captured by the Martian orbit. The TSV will be docked to the ISS by the crew quarters. From this point, it will depart to Mars, first by undocking from the ISS and moving far from it before firing its main rockets to leave the Earth's attraction. The lander consists of two sections: the crew section, which will be the return to orbit vehicle, and the landing section that will take it to the surface in a soft landing. This section has the Mars rover in an inner compartment. These next two slides show the landing stage, which has the landing pads, landing engine, and a tubular section that contains fuel compartments and the Mars rover. The idea to make a tubular is to make the spacecraft lighter. This section is protected during the atmospheric re-entry by a heat shield. In this view can be seen the four lift-off engine exhaust tunnels for the upper stage, and also the landing engine and the Mars rover storage area. The Mars crew headquarters or unmanned landing module is the element that will be sent to the surface and will serve to the crew as the first Mars station. It is inside a container that will be used as heat shield during the landing and will be shown later. The second largest structure of the unmanned is the unmanned Mars vehicle that will have some elements to be used when the manned vehicle arrives, for the exploration of the planet and for the return to Earth if needed. This vehicle will be sent before the manned mission. It consists of a backup landing module and a crew supplies module. Also two propulsion modules that could be used in the return to Earth if needed. This structure could be kept on an orbit of Mars for future missions or orbital observation. The mission flight plan, the main points are: the unmanned vehicle is assembled and tested in Earth's orbit, then initiate its journey to Mars. While this vehicle is going to Mars, the TSV is assembled in Earth's orbit and the modules arrive from Earth. When it's complete, it initiates the journey to Mars. The Mars manned vehicle reaches Mars at the time the unmanned vehicle should be orbiting Mars already. Then is the Mars exploration, orbital and surface. Then the Mars to Earth journey and an arrival of the Mars manned mission to the ISS. The unmanned vehicle is assembled in orbit and while docked on the ISS. When ready and tested, will undock from the ISS to begin its journey to the orbit of Mars. where it will be positioned in a stationary orbit until the manned vehicle arrives. Mars Manned Vehicle Journey to Mars. The Mars vehicle will be undocked from the ISS to begin its journey to Mars. The undocking will begin by firing small rockets to move the Mars vehicle away from the ISS to a safe distance from it. Then will fire its rockets to abandon the Earth's gravitational pull. At arrival, will fire its rockets to reduce speed and be captured by the Martian gravitational force. At this time, the unmanned vehicle will be also in orbit around Mars. From the Martian orbit before the landing of a module on unmanned or manned, this probe will be sent to collect and relay information of the atmosphere during its entry, to be able to load all the parameters needed for the actual landing and determine that the conditions are safe and favorable for a landing. The probe will crash on the surface. No soft landing option is considered at this time. Some of the data that will be transmitted is wind speed, temperature, atmospheric composition, dust density. The unmanned crew supplies will be directed to a specific area to allow the crew to reach it later. It is released from the TSV. The landing sequence will take it to a soft landing. After the atmospheric friction ends, the parachute will open and the heat shield jettisoned. Landing pads extended, landing engine start, and finally arrival to the surface. Shutting down the engine, and a radio signal will be sent to the orbiting vehicle to announce that it has landed safely and to calculate its exact location. The crew headquarters model is directed also to land in an automatic mode to a specific area near the previous model, so where the crew lands will be able to reach it with the rover. The next 3 slides show the landing sequence beginning with the separation of the model from the TSV. First, the model is undocked from the TSV and begin atmospheric entry. The enclosure that protects the model during the entry and acts as heat shield will be opened by some pyrogenic mechanism, then pushed up and away from the actual landing module trajectory. Parachutes are deployed, landing pad extended, landing engine started, correction engine fire, landing and engine shut down. At this point, the module will begin to send signals to the orbit indicating that it has arrived safely. These signals will allow calculating the exact position from it. From orbit, the crew can begin to activate its systems and perform some preliminary tests to be sure that it's operating correctly and is ready for use by the crew. Once in the surface, when the crew arrives, the module batteries will be reloaded by solar panels and windmills. The activation will be completed. After the safe landing of the unmanned modules, calculations are made for the landing of the crew. The next 3 slides present the landing sequence of events of the crew on Mars. In this slide, the crew landing vehicle is positioned to the departure point by the RMEs of the TSV. Once there, it will be released and will fire its entry rockets to begin its descent to the Martian atmosphere. The landing sequence will begin with the release of the heat shield and move aside by small rockets to avoid collision with the spacecraft. Landing pads extended, landing engine is started, and parachutes deployed. Finally, the parachutes are released, descending correction zones, touchdown, and the engine stop. At this point, the first humans will have arrived to the surface of Mars. As in previous cases, a signal will be sent to the orbit space vehicle to let them know the position of the landing. During the landing, there are abort procedures if needed. On the surface of Mars, the crew will lower the Mars rover to the surface and will travel to the crew module that landed before and to the supply vehicle. In this particular slide, these elements are together, although the crew lander